visiting dignitaries, fellows of the college, the ninth Victor Anumanu lecture. This lecture, as you've heard, was instituted to recognize the contributions of the founding spirit of our great college to research and indeed clinical practice. It is keenly competed for every 2 years, and I'm indeed grateful to the executive of West African College of Surgeons for giving me the privilege to introduce the ninth Victor Anumanu lecturer. In this very great hall, I gave the fifth Victor Anumanu lecturer, and I guess that's why I've been asked to read his citation. Will Professor Temidayo Ogundiran please rise? Professor Temidayo Ogundiran is a professor of surgery at the College of Medicine, University of Ibadan in Nigeria. He left secondary school in 1976, following which he attended post-certificate grade 2 Teachers College, where he emerged as the best student in the class. He was a classroom teacher in both primary and secondary schools for 5 years before attending the University of Ibadan for his undergraduate medical training, from where he graduated with a prize as the best student in the Department of Medicine in 1988. Thereafter, he did his one-year internship at the University College Hospital, Ibadan, and again won the award as the best houseman of the year 1988-1989. He pursued postgraduate training in surgery at the same hospital and became a fellow of our great college in October 1996. He then went on to become a fellow of the Royal College of Surgeons of Edinburgh in June 1999. He received post-fellowship training in oncology at the Massachusetts General Hospital at the Dana-Farber Cancer Institute in Brigham and Women's Hospital and Memorial Sloan Kettering Cancer Center, all in the United States of America. He also obtained a master's degree in bioethics from the University of Toronto in 2004, and he was an exchange scholar at the Department of Biometry, Medical University of South Carolina, Charleston, USA in 2001. He's a recipient of the American Association of Cancer Research Training in Molecular Biology and Clinical Oncology at the Given Institute at the University of Colorado, Aspen, USA in 2006, and was a visiting fellow at the Cancer Signaling Unit, Chinese University of Hong Kong in 2007. In 2010, he attended the Wellcome Trust Advanced Course in Genomic Epidemiology in Africa at the Kemri Wellcome Trust Research Program, Kilifi, Kenya, and at the University of Dundee Summer School on Epidemiology and Global Health. Professor Ogundiran is involved in clinical epidemiology and genetic research, and he has been the local PI in the study on genetic epidemiology of breast cancer research in Blacks, in collaboration between the University of Ibadan, Nigeria, and the University of Chicago in the United States. He has also collaborated in cross-cultural studies of informed consent in the United States and Nigeria, and is the coordinator of the West African Bioethics Program, a multifaceted National Institutes of Health funded initiative that runs an MSc Bioethics program at the University of Ibadan. This conducts online bioethics molecular training and trains various candidates in research ethics across West Africa. As a scholar and academic surgeon, Professor Ogundiran has contributed to 9 chapters in books, 86 scientific articles in peer-reviewed journals, and more than 25 scientific abstracts and proceedings. As a measure of the worth of his research publications, at least 10 of his papers have over 200 citations in the Google Scholar. He has attended over 80 scientific conferences at home and abroad, and given more than 100 presentations in scientific conferences and workshops, and has also given 26 public health and cancer awareness lectures in markets, religious centers, and other public places. He has supervised research projects of 24 projects at undergraduate, master, and PhD levels, and has contributed to the training of at least 8 fully fledged general surgeons who have obtained the fellowship of our college. He has received many scholarships, grants, and honors, and has been a past or current member of many local and international academic and professional bodies, including the International Affairs Committee of the American Society of Clinical Oncology, the Emergency Care Ethics Working Group of Fogarty, the National Institutes of Health, and the Joint UI-UCH Research Committee. He's also a member of many academic and professional societies at home and abroad. Importantly, he was a co-winner of the much coveted Nigerian Academy of Science Gold Medal Prize in the Life Sciences for 2018, which award lecture he gave just last week. So it seems as if he's making this a weekly event. He's presently on loan from the University of Ibadan to the World Health Organization as a visiting professor of surgery at the College of Medicine and Allied Health Sciences in the University of Sierra Leone, and is a consultant surgeon at the University of Sierra Leone Teaching Hospital Complex, Connaught Hospital, Freetown. Professor Mudira is happily married and has been accompanied to this meeting by his wife and one of his 3 children, aptly named Treasure. It is my great pleasure to invite Professor Temindai Okundino to deliver the 9th Victor Anoma Ngo Lecture of the International College. Professor Okundino.
President of the West African College of Surgeons, members of council, past presidents, fellows, and members of the college, distinguished dignitaries, ladies and gentlemen. I would like to thank the President and Council for approving my nomination to deliver the 9th Victor Anoma Ngo Lecture at this 59th Annual Scientific Conference of the College. This indeed is a great honor as well as a great privilege for me to be so nominated. My selection is also an exceptional honor to the College of Medicine, University of Ibadan, and its University College Hospital, UCH, Ibadan, Nigeria. The twin institutions where I have been planted, cultivated, nurtured, and cultured over the past 37 years as medical students, surgical trainee, and staff member. These institutions provided me the wherewithal to be a fellow of this college, and even more, want to stand before you as it is this day. It is also an honor to the College of Medicine and Allied Health Sciences, University of Sierra Leone, and its teaching hospital, where I've been a visiting professor since 2017. Let no one be envious of my admittedly esteemed presence the next hour or so on this lecture platform. For I stand before you in trepidation of the fact that 8 previous highly distinguished and more qualified speakers have occupied this position before me in times past. Moreover, I've been called upon to follow in the steps of 3 giants from one of the institutions that I represent today. The very first and foremost Victor Anoma Ngo lecturer, the one and only Jagun Asho, past president, Professor Olajide Ajayi, whose great attributes and enviable credentials I'm too small to read. Professor Emiola Uluwapunmi Olapade Olaogba, a distinguished professor of surgery, of urology, and the 5th Anoma Ngo lecturer whose accomplishments and influences are as tall as his height and as long as his name. And Professor Akeem Olawale Lasisi, an energetic dynamic, and highly accomplished professor of otorhinolaryngology and the 7th lecturer. While I cannot and will not attempt to match these previous speakers in content, in quality and oration, I hope you will receive my lecture as a modest contribution towards honoring an eminent surgeon whose name this lecture bears. The man, Anoma Ngu. Professor Victor Anoma Ngu, born a Cameroonian, but an African in nationality, was the first African head of Department of Surgery, University College Hospital, Ibadan, from the year 1965 to 1969. His professional career spanned almost 5 decades and 3 continents. In his brief 84 years sojourn on Earth, he was many persons rolled into one: a clinician, a professor of surgery, a pioneering officer of WACS, a clinical translational researcher, an inventor, a university administrator, a national government minister, a president of associations, a director of cancer research laboratory, a hospital director, and a recipient of many national and international honors, prizes, and awards. As a pioneer that he perennially was, Professor Ngu established the Ibadan Tumor Clinic in the Department of Surgery, UCH, Ibadan, in 1964. The clinic was to cater for bronchitis, tumor, and breast cancer. Over the years, the clinic has evolved into a major surgical oncology division that is actively involved in surgical training and career research and cancer research and management. Professor Ngu would later receive a Rockefeller Foundation Fellowship to train in cancer chemotherapy, work on immunotherapy of cancer, and ultimately be recognized with an Albert Lasker Medical Research Award in clinical cancer chemotherapy, among many others. As a graduating doctor from St. Mary's Hospital Medical School, University in 1954, he was the only black student in the class. He received the Max Born Prize and Medal in Pathology with a handshake from the Queen Mother of England, the same award that she had earlier presented to Sir Alexander Fleming for his discovery of penicillin. From sunrise to sunset, his life, which can be likened to an Iroko tree, small beginning, deep-rooted, tall, wide stem and bough, flourishing branches and leaves, was lived to the full. In spite of all his achievements and recognition, he was such a self-effacing gentleman that an articulate past Secretary General of this college, Professor Bode, described him as humble beyond humility. At his death, some of the epithets from the fellows of the college, as put together by Professor Bode, read as follows: the great fish swam away into the deep. A lion goes to sleep. The Iroko tree is falling. It is this great fish of the deep, this lion king of the jungle, and this great Iroko tree that this lectureship has been established by the college to honor. Now let me go into why we're here, by starting with a brief overview of cancer. Well, we can see from this picture 4 generations of surgeons. We can see on the your extreme right, one small person there standing, gazing into the future, as if Jagun Ashu was telling him, Dayo, follow me, you will soon give this lecture. Before I plunge deep into the focus of this presentation, which is on breast cancer, let me quickly refresh our memories on some general information about cancer. First, why does cancer occupy such an important topic for discussion? 1. In his book on the history of cancer, The Emperor of All Maladies, Mukherjee narrates the story of many diseases, all of which are called cancer, because they share a commonality, that is the abnormality of growth of cells. The story of cancer is old as the story of man. It is a story that has been characterized by human ingenuity, resilience, perseverance, as well as hubris and misconception. The knowledge of cancer as disease has spanned more than 4,000 years. and much has been written about it in past centuries. However, the knowledge of the science of cancer did not begin until after 1838, when Matthias Schleiden, a botanist, and Theodor Schwann, a physiologist, both working in Germany, proposed that living organisms were made of building blocks called cells. Building on this knowledge, another German, a pathologist, Rudolf Virchow, set out to create a cellular theory of human biology. In his work, he showed that cells arose from cells, hominis cellula, e cellula. He described hypertrophy and hyperplasia. Of hyperplasia, he said, hominis cellula, e cellula, e cellula, meaning cells becoming more cells. Although then oblivious of the mechanism, Virchow was he who used the word neoplasia to describe pathological hyperplasia, that is cancer, a word that paved the way for the flurry of activities that have taken place in cancer research in the past 2 centuries. According to the World Health Organization, cancer is the leading second cause of death globally. 1 in every 6 deaths is cancer-related. In 2015, cancer killed 8.8 million people, with about 70% occurring in low and middle-income countries of the world. Although the poor control and persistence of old infections and the emergence of new ones in Africa make infections to still remain a major source of morbidity and mortality in this part of the world, current data, however, show that cancer kills more people than HIV, AIDS, tuberculosis, and malaria globally. The burden of cancer is ever increasing globally, almost on a yearly basis. The following figures are shown from the WHO agencies on new cancer cases and mortalities bear this fact out. The figures are projected to rise to 28.4 million new cases, with 17 million deaths by the year 2030. It is thus pertinent to ask, what are the factors that are driving the increasing global cancer burden? 3 major factors have been profiled. 1, there has been an increase in world population. World's population increased from 6.1 billion in 2000 to 6.7 billion in 2008. It is estimated that this figure will rise to 8.3 billion in 2030. Even if cancer age-specific rates remain constant, increase in world population alone will escalate the burden. 2, aging is a major factor for cancer as well as many non-communicable diseases. Aging has progressed most steadily in high-income countries, but the low-middle-income countries are not left out altogether. Global health statistics show that life expectancy increased by 5 years between 2000 and 2015, the fastest increase since 1960. This increase was greatest in the African region of WHO, where the average life expectancy increased by 9.4 years to 60 years. And this is illustrated in the chart, as we can see, illustrating Nigeria, Sierra Leone, Senegal, and Singapore. We can see that from 1960 to date, the average life expectancy has been increasing. The third factor is an underlying increase in the true incidence rates of cancer, even if population size and age distribution were to remain constant. The increase in incidence rate is due to a combination of the effect of increasing exposure to carcinogens and lifestyle modifications. Cancer is also associated with profound psychosocioeconomic issues. The diagnosis of this malady causes unpleasant psychological and emotional reactions. The care of cancer is usually intensive, disruptive, and often prolonged. The economic cost of cancer is enormous. In 2010, the total annual economic cost of cancer was estimated at US $1.16 trillion. Moreover, the outcome of cancer management is often unpleasant, especially in settings of limited resources. Early diagnosis and prompt treatment, however, enhance good outcome in many cancers. Again, some cancers are preventable. The WHO estimates that 30 to 50% of cancers are preventable. For example, a third of cancers in the developing countries are due to infections, most of which are eminently treatable and preventable. Moreover, surgeons are in the forefront of cancer management. In addition to the reasons adduced above, a lecture that is devoted to cancer is indeed apt in a gathering like this, because cancer represents a great burden of non-communicable diseases that surgeons manage. Surgery actually remains the primary treatment for solid tumors. Surgery is employed for screening and prevention, diagnosis and staging, treatment and rehabilitation, as well as for palliative care and for managing cancer emergencies. Furthermore, Victor Anoma Ngu devoted his life and career to the study and management of malignant diseases. Now, carcinogenesis. Cancer is a multi-stage progressive disease process that involves a complex interaction between an individual, that is, his heredity and his lifestyle practices, and his environment, that is, exposure to carcinogens, cancer-causing agents. These altogether working in a complex relationship result in the transformation of normal cells to tumor cells. Carcinogens are classified into physical, chemical, and biological. And generally speaking, the list of factors that have been identified as causing cancer is endless. In cancers, cells undergo profound metabolic and behavioral changes that result in ultimately untimely and excessive proliferation or multiplication, such that the body's immune response or surveillance is escaped, leading eventually to the tissue invasion and distant metastasis. These changes arise as a product of modification in the genetic programs that control cell proliferation. Alterations at the cellular level result in genetic dysfunctions that either excite the activities of oncogenes, cancer-causing genes, or deactivate the activities of tumor suppressor genes, leading to uncontrollable cellular proliferation. On one hand, genetic mutations modify the DNA sequence, which in turn results in the synthesis of abnormal proteins that promote cancer process. These changes are detectable by sequencing the DNA of cancer cells. On the other hand, another way of altering cellular programs, thereby leading to cancer, is to modify the packaging of DNA by shutting down some genes along the DNA or by switching on others. These changes, called epigenetic, are identifiable by analysis of chemical modifications that regulate DNA accessibility and readability. Both genetic and epigenetic changes are like two sides of the same coin. Both work in synergy, and are universally present in human cancer. The causes of genetic and epigenetic changes are numerous, including a variety of chemical, physical, and toxicological agents, resulting in mutagenesis and accidents in the physiological process of DNA replication and repair. Overall, tumorigenesis, causation or development of tumors or cancers, require violation of three fundamental rules. 1, cellular division should be preceded normally by appropriate signals from a hormone or a chemical, a growth factor. To break this rule, the cell permanently activates the on switch, the oncogene, so it continues to repetitively produce. 2, when cells can encounter harsh conditions for DNA replication that will result in gene damage, self-destruction programs are activated. When this autoregulatory system is bypassed or deactivated by whatever reason, the safety brakes that present aberrant or excessive cell division are removed, called tumor suppressor genes. 3, normal cellular proliferation is controlled by regulatory counter, such that cell division is calculated to a predefined finite number. This counter is telomere, which is situated at the end of each chromosome. The telomere consists of small repeats of DNA sequence, which becomes eroded with every cell division until it becomes depleted. As cells divide, as the genes divide, the telomere becomes depleted. But there's an enzyme called telomerase, which repetitively adds new DNA repeats, thereby propagating cellular division beyond the normal program of the cell. A would-be cancer cell operates these changes with genetic susceptibility and environmental changes playing, triggering, enhancing, and propagating roles. Now, let's talk about breast cancer in Africa. briefly before I go into the genetics. Breast cancer is the commonest female cancer worldwide. Its incidence has been increasing in African populations that previously enjoyed low rates. It was the second most common malignancy of women in sub-Saharan Africa 4 decades ago. In Nigeria, for example, data from the University College Hospital Ibadan Tumor Registry show that the hospital prevalence of breast cancer rose from that of cervical cancer in the period between 1960 and prevalence of breast cancer rose over that of cervical cancer in the period between 1960 and 1980, compared to the period between 1981 and 1985. A recent review has shown that breast cancer incidence in Nigeria has increased from 13.7 in 1960 to 50.4 in 2012 per 100,000 women, with a projection of 84.2 in the year 2030. The number of women at risk of breast cancer increased steadily from approximately 24.5 million in 1990 to approximately 40 million in 2010, and is also projected to rise to about 50 million by 2020. In addition to the rising incidence of male breast cancer in Africa, the epidemiological, demographic, and clinical characteristics of the disease make it a matter of grave public concern. Although some marginal improvements have been noticed, the demographic and clinical pattern of presentation has not changed significantly over the past 3 or 4 decades. Now, let me go to the Nigerian breast cancer study. The Surgical Oncology Unit in the Department of Surgery, UCH Ibadan, is the oldest oncology unit in Nigeria. In 1997-1998, a discussion ensued between 2 colleagues working on the 2 sides of the Atlantic. One, a surgical oncologist, the other a medical oncologist. Both had a common interest in breast cancer, and through the intermediation of a 3rd colleague, they both agreed to work together to study the disease in Black people in some detail. What started as an exploration of a common pursuit by both soon metamorphosed to what became known as the Nigerian Breast Cancer Study. The Nigerian Breast Cancer Study is a collaboration between the University of Ibadan, Nigeria, and the University of Chicago, Illinois, US. The overarching goal of this partnership, which has spanned more than 2 decades, was to study the genetic epidemiology of breast cancer in Blacks. This was premised on the observed disproportionate burden of premenopausal breast cancer in Africans compared to other racial or ethnic groups for reasons unknown. The pursuit was to investigate the genetic and non-genetic basis for the observed disparities in age-specific incidence and mortality in African women and women of African ancestry through a case-control study. At the commencement of this work, it was about the first of such collaborative study on breast cancer. The Nigerian Breast Cancer Study was a hospital-based study of invasive breast cancer conducted in Ibadan. Before commencing, the study was approved by the Research Ethics Committee of both the Universities of Ibadan and Chicago. And as necessary, this approval was renewed over time. Trained nurse and interviewers recruited participants into the study and administered questionnaire and so many other things. All breast cancer cases aged 18 years and above who came to UCH then were recruited. Controls were recruited from Abalamu community in Akwata area of Ibadan, and later from UCH. They were females aged 18 years and above without any type of cancer at recruitment and who were able to give consent. At the onset of this study, the research process was based fully in the Department of Surgery. In UCH, the local research staff were 2 surgeons, my boss and myself, 1 histopathologist, 1 laboratory technologist, and 2 registered nurses. The Department of Surgery gave us full collaboration and support. All recruitments were done, and at the end of each clinic, tumor biopsy was done by surgeons. Thereafter, tumor and blood processing was carried out the same day in the surgical research lab. And in the early years of the study, we extracted DNA from biological specimens in the surgical research lab, and this was later shifted to the Institute of Advanced Medical Research in the College of Medicine. Germline DNA extraction took place in our lab, while further genomic sequencing and genotyping was done at the University of Chicago. In the second phase of the study, we developed more capacity, which included collaborating with other studies across the world. Now, let me go into findings from the Nigerian breast cancer study. And I will discuss this under the following headings: anthropometrics, reproductive factors, lifestyle factors, risk prediction model, genetics, hereditary breast cancer, and others. I will try to be snappy with each. Now, anthropometrics. We set out to dispel or confirm the documented association between obesity and breast cancer in the Western world in a solely indigenous African cohort. The waist-hip ratio had been validated as a measure of central adiposity. More importantly, the metabolic effect of obesity and the increased level of peripheral aromatization all serve to increase the risk of breast cancer in patients. The important methods of assessing and predicting obesity using the body mass index and waist-hip ratio were employed. Also of note was the stratification into pre- and post-menopausal categories, respectively. Our studies showed that age at menarche, that is, age at first menstruation, height, weight, irregular menstrual periods, obesity with BMI greater than 30, and social status are predictors of breast cancer in all women. The data also confirmed an association between waist-hip ratio and the risk of breast cancer in post-menopausal women. Being the first of such epidemiological studies in our setting, the association in post-menopausal women improved our understanding of the relationship between obesity and breast cancer in Nigerian women. Over the next 11 years, we recruited more patients, almost about 3,000 patients and controls for the study to have more power and better detect effects that could be small earlier on. The conclusions then were that an elevated waist circumference and waist-hip ratio was associated with an increased risk of breast cancer regardless of BMI state. Furthermore, cases overall were on average 1.4 centimeters taller than controls, and a positive relationship existed between height and breast cancer for both pre- and post-menopausal women. It's noteworthy to note that for every 5 centimeter increase in height, the risk of breast cancer increased by 22%. Reproductive factors. Prior to our work, few studies had examined the risk of breast cancer in Nigerian women, and fewer still had systematically examined the association with reproductive factors in sub-Saharan Africa. Therefore, in the period between the 8th and 15th years of our study, we examined a wide range of such factors on breast cancer risk among Nigerian women. We included data from Yaoundé, Cameroon, and Kampala. Yaoundé, Kampala, and Uganda later. Kampala and Uganda. They were included in the analysis later in the study. The majority of women had their menarche about 15 years of age, and age was inversely associated with breast cancer risk. In the age-adjusted analysis, women with menarche at or after 17 years showed about 40% lower risk than those with menarche at less than 17 years. Cases were more likely than controls to be nulliparous, and there was an inverse trend between parity and risk. To examine how the prevalence of reproductive factors changed for women born in earlier and later decades, we grouped healthy controls into 5 back cohorts. The average age at menarche decreased over time from 54% before age 17 years for women born before 1940, compared with 77% for those born after 1970. The number of pregnancies and live births were also significantly decreased over time among all women. The mean age at first live birth did not change substantially over time for parous women, but there were more nulliparous women in the recent birth cohort. The proportion of women that had their first child before age 25 years was significantly decreased from 73% in the oldest cohort to 36% in the youngest cohort. And the lifetime duration of breastfeeding also decreased markedly over time, partly due to smaller family size and partly due to shorter duration of breastfeeding per child. On the basis of the odds among the cases and the secular trend of the reproductive factors in the controls, breast cancer incidence was estimated to have increased 7% due to change in menarcheal age, 15% due to decreased parity, and 15% due to shortened duration of breastfeeding per child. Previous work had also stimulated the debate about whether the protective effect of full-term pregnancies on breast cancer risk were beyond the first one. In our cohort, we found that risk decreased by 5% for each additional birth after the first birth, and by 7% per 12 months of breastfeeding. Therefore, we concluded that multiple live births, extended breastfeeding, later onset of menstruation are protected in Nigerian women. In spite of this, however, we noticed that the protective role of these reproductive factors were changing in the direction of increased breast cancer risk. We estimated that risk increased by about 37% in women born in 1960s compared to those born in 1930s due to change in menarcheal age, parity, and duration of breastfeeding. Therefore, incidence in the Nigerian population might have increased in the past 3 decades and may continue to increase further if the trend continues. Furthermore, we explored the influence of pregnancy on breast cancer risk by looking at the time of diagnosis of breast cancer from last pregnancy onward. It is known that pregnancy invokes 2 potentially opposing influences on the mother's risk of breast cancer: a transient increased risk in the years immediately following pregnancy, and a long-term protective effect. Time interval for this postpartum increase in breast cancer was estimated to range between 12 and 15 years. There was a significantly greater proportion of non-pregnancy associated breast cancer cases with a family history of breast cancer compared with others. In contrast with non-pregnancy associated breast cancer cases, PABC cases at 2 or fewer years postpartum were more likely to carry BRCA1 or 2 deleterious mutations. We observed a tendency toward positive association between parity and pregnancy-associated breast cancer at 2 years or less postpartum, and a tendency towards inverse association between parity and non-pregnancy-associated breast cancer. We concluded that parity may have different roles in the development of pregnancy-associated breast cancer versus other premenopausal breast cancer in Nigerian women. Prospective mothers with multiple births and a family history of breast cancer may have an elevated risk of breast cancer during their immediate postpartum period. Environmental factors. We studied 2 things: alcohol and physical activities. Alcohol has been established as a risk factor for breast cancer, and the hypothesis behind this is that it causes genotoxic effect from acetaldehyde and ethanol. It also acts as a solvent for other carcinogens to act, and it also causes the production of reactive oxygen and nitrogen species, which are toxic to cells. And of course, it also causes nutritional deficiencies like vitamin A deficiency and reduces immune surveillance. And specifically for breast cancer, there is strong evidence that alcohol increases estrogen level. It also alters folate metabolism. The prevalence rates vary by country in Africa, but in general, alcohol drinking was less common among African women than their counterparts in North America and Europe. However, the trend is changing towards greater prevalence of consumption. The study population was 4,727 cases and controls from Nigeria, Cameroon, and Uganda. Among healthy controls, the overall alcohol consumption prevalence was 10.4% in Nigeria, and the prevalence, was 10.4% generally. And the prevalence in Nigeria, Cameroon, and Uganda were 5, 3.4, 34.6, and 50% respectively. Women in Cameroon and Uganda were more likely to be current drinkers than those in Nigeria. Among women in Cameroon and Nigeria, current drinking was proportionately more common in middle-aged women than younger or older women, while in Uganda, young women aged 18 to 34 had the highest prevalence of current drinking. Cases were found to drink for 2.8 years longer on average than controls. About 15% consumed at least 1 drink per day. 1 drink is equal to 14.4 grams of pure ethanol. In drinkers, there was no considerable difference in amount of alcohol drinking among the 3 countries. In calculating the relationship of the alcohol drinking patterns to breast cancer risk, cases were more likely to have consumed alcohol. Both past drinking and current drinking were associated with breast cancer risk, and the risk was relatively consistent regardless of when the women first started drinking. Compared with non-drinkers, women who had drunk for less than 10 years had 41% higher odds of breast cancer. Those who had drunk for 10 to 19 years had 71%, and those who have taken alcohol for or greater than 20 years had 82% higher odds of having breast cancer. Every 10-year increase in the duration of drinking was associated with a 54% increase in breast cancer risk. We also found that alcohol consumption was associated with breast cancer risk regardless of the amount that was taken. An additional observation was the interaction between alcohol drinking parity and BMI on the subject's predisposition to breast cancer. Among women with BMI greater than 25 kilograms per meter squared, ever drinkers had nearly twice the odds for breast cancer than never drinkers. There was no statistically significant association between alcohol consumption and breast cancer among women with BMI less than 25. This suggests that obesity and alcohol drinking have joint effects on risk of breast cancer in women. The conclusion from the foregoing is that there was a positive relationship between alcohol consumption and breast cancer risk among sub-Saharan African women, and a dose-response relationship was established with alcohol, with 10-year increase of drinking associated with 54% increased risk. Alcohol is a modifiable risk factor which should be addressed in breast cancer prevention programs in Africa. Physical activity. This has been linked to decreased breast cancer risk, particularly among postmenopausal women. It was estimated that the protective effect of physical activity on breast cancer ranges from 15 to 30% among premenopausal women and 20 to 80% among postmenopausal women. Therefore, we looked into this. We designed a new module that incorporated the question right from the beginning, and we incorporated questionnaire on alcohol drinking. In Nigeria, Cameroon, and Uganda, we observed that African women's physical activity mainly consists of housework activities and work-related activities, with little activities conducted for recreational purposes. Our study showed that overall physical activity was significantly associated with reduced breast cancer risk in both pre- and postmenopausal women. Women who engage in 25 or more metabolic equivalent of task hour per day of total activity had approximately 60% lower risk of breast cancer than the least active women. The activity level of 25 met hour per day translates to about 6 hours of brisk walking per day. Even light intensity physical activity was associated with lower breast cancer risk. All said, we see that physical activity of African women consists mainly of housework and work-related activities, and physical activity was significantly associated with reduced breast cancer risk in both categories of women. Now, let me go to the Nigerian breast cancer risk prediction model. Ideally, women at increased risk for breast cancer should be accurately identified so that appropriate surveillance and prevention strategies can be offered. This strategy has already contributed to a decrease in incidence in developed countries. The risk-stratified screening strategy is particularly important for countries with low incidence where cancer patients often present late due partly to low awareness and late detection. Unfortunately, there has been no any such for sub-Saharan Africa. The breast cancer risk assessment tool, also known as the GALE model, has been widely used in white women. The model was later modified for use among African American women. Researchers from the Black Women's Health Studies developed another risk prediction model using a prospective cohort of African American women aged 30 to 69 years. However, none of them were tested for application in indigenous women in sub-Saharan Africa. Therefore, it was necessary to develop accurate risk prediction model for sub-Saharan African women based on data collected from indigenous populations in this region. To this end, we pulled our data together from 1998 to 2015 to develop and also validate an absolute breast cancer risk prediction model for sub-Saharan Africa. We also compared the performance of the developed model with the GALE model for white population and the GALE model for black population and the Black Women's Health Study model. The tool was developed from the data of more than 4,000 subjects. To develop the overfitting issue in model building, 2/3 of the subjects were assigned to training and the other third to validation. So The process of arriving at an absolute risk prediction model passed through so many complex statistical stages. The final model built using the training set included 9 variables, as you can see them on the board. For those who are here and cannot see, these were age at menarche, number of live births, duration of breastfeeding, benign breast diseases, family history of breast cancer and the first degree relatives, height, BMI, and alcohol consumption. Comparing the 4 models, the discriminating accuracy, that is the C index of the Nigeria breast cancer model was 0.7, which is significantly greater than the other 3 models. Moreover, the NBCS model, that is the Nigerian model, presented a good agreement between observed and predicted 5-year risk over the whole range of probabilities. The other 3 models did not perform well. The distinguishing ability of the Nigerian breast cancer model was significantly better, as you can see from this slide, at the threshold of 0.9% and 1.66%. In the Nigerian breast cancer model, 95 cases had 5-year risk greater than 1.66%, compared with 19, that is 0.9% controls, using a 6-fold difference. And at the threshold of 0.9%, 20.7 cases could be detected at the expense of 6.8 controls being screened. The Black Women Health Study model gave higher estimates of 5-year risk, but these risk estimates cannot distinguish cases and controls, as we can see on the board. Both their models using Nigerian incidence rates gave an overall low incidence of risk. So the summary is that these models are not applicable for our women in sub-Saharan Africa, and that the Nigerian risk prediction model has worked well. To summarize all the above, among Nigerian women, our model performed better than the other models, and of the variables used, 6 of them were already incorporated in other models before us. As a result of this work, an online risk calculator and a downloadable standalone Windows package calculator for the Nigerian breast cancer model to do individual risk projection and counseling are available, as is shown on the board. We can just go into this site, plug in those the information requested, age and all that, and then click the button. Then it will bring out the prediction for 5 years, for 15 years and more. And we compare that with the population risk so that somebody can know what the risk of developing breast cancer is for her. Now, what is the public health implication for this? First, early detection to improve outcome and survival remains the cornerstone of breast cancer control, and this is urgent in sub-Saharan Africa. Second, our country faces resources constraints that limit the capacity to universally screen with MRI and other high-falutin stuff because of cost. Our risk prediction model tool is low cost, based on questionnaires and physical examination, implementable in limited resource settings to identify the high-risk populations for further screening. Third, the mean age at diagnosis of sub-Saharan African women is more than 10 years younger than American women. Therefore, screening and using the guidelines of the American population will mean that many breast cancer cases will be missed. Lastly, because of the common ancestry shared by sub-Saharan Africans and African American women, our work may provide some inspirational clues to improve the existing model for the African American women. Now, let me go to the final phase of the discourse by talking about genetics. Cancer genetics comprises 2 main fields: genetic susceptibility and somatic cell genetics. Genetic susceptibility focuses on inherited, that is, constitutional germline genetic variation in cancer susceptibility genes, while somatic cells focuses on mutations that arise in an individual's cells during their lifetime. Cancer genetics pertain to the role that these inherited variations and mutations play in tumor initiation and progression. Biochemically speaking, cancer susceptibility genes are 3 types. One, I've mentioned them before: oncogenes, which are required for tumor initiation, tumor progression, invasion, and metastasis, either by overexpression or gain of function mutations. We have examples like RAS and MYC oncogenes. Then tumor suppressor genes, these act opposite to oncogenes by inhibiting the process required for tumorigenesis. They become tumorigenic when they are underexpressed or when there's loss of function mutation in them. Examples include TP53, BRCA1, and so on and so forth. Then we have the risk modifier genes. These ones modify the risk due to a carcinogenic exposure, like environmental or genetic. These genes fall into spectrum from high risk to, we can also classify them into high risk as well as low penetrance genes. High risk susceptibility genes for breast cancer include BRCA1, the common ones we all know, BRCA2, TP53, CHEK2, and so on. They are fairly well explored, and much is known about them. However, a large proportion of the familial cancers are probably due to gene mutations and polymorphisms in the low penetrance genes. The past 2 decades have witnessed an explosion in knowledge of molecular biology and discovery of novel genomic technologies. Scanning the whole human genome was made possible following the complete sequencing of the human genome, and additional information has been provided by the International APMAT project. Interestingly, our surgical oncology unit was one of the participating centers for the APMAT project. There has been an intense search for these cancer susceptibility genes using the Genome-Wide Association Studies, GWAS, and this is made possible by the increase in technology in the world today. Most studies of BRCA1 and 2 breast cancers, Australian breast cancers were done in white people, so we thought that we should look at our population. Now, let's look at hereditary breast cancer in Nigerian women. Our first work on the genetics. Before they take care, you can use the Our first work on the genetics of breast cancer was to screen young women under 40 years of age with breast cancer for BRCA1 and BRCA2 mutations. We determined the frequency and mutational spectrum of these genes by using single-strand conformation polymorphism. Let me leave out all this. 2 novel truncating mutations, BRCA1 mutations, and 1 protein truncating BRCA2 mutations were identified, and one of the mutations was identified in a kindred with 3 cases of breast cancer among first-degree relatives. In addition to these truncating mutations, 4 amino acid substitutions were also detected in BRCA1. The conclusion from this first work was that 4% of the population carried deleterious mutations, and a significant level of genetic variation in BRCA2 occurred in this African population. This preliminary data suggested that there's a significant role for BRCA1 and 2 mutations or sequence variations in cases of early breast cancer from Africa. In another cohort, we sought to better define the frequencies of these mutations in BRCA1 and 2. And we found a single known deleterious truncating BRCA2 mutations and no additional truncating mutations in 39 patients. The mutations identified in BRCA2 in this cohort were distributed throughout the coding region, with several amino acid substitutions occurring more than once. Moreover, several observations suggested that some of these mutations might represent deleterious or incompletely penetrant alleles. Now, taking all this together, what does it mean? The observations suggested that the high variability of BRCA1 and 2 sequences could contribute to early onset breast cancers in African populations. These observations expanded our previous work and was consistent with observations by other workers. We further completed sequence analysis of all BRCA1 and 2 exons and intron exon boundaries for 434 patients, unselected for age of onset, family history, or any other criteria that would enrich for BRCA1 or 2 mutation carriers. The focus was only on mutations that were presumed to be disease-associated, and there were 31 BRCA1 mutation carriers, given a prevalence of 7.1%. Additionally, we also identified 17 BRCA2 mutation carriers and 16 different BRCA1 mutations were detected, 7 of which had never been reported previously, while 13 different BRCA2 mutations were seen. Carriers of recurrent mutations accounted for 74.2%. Moreover, there was a higher proportion of BRCA1 carriers in the under 50 years age category than in the over 60-year age category. Patients with a family history of breast cancer were twofold more likely than patients without a family history to carry a mutation in BRCA1 or 2. Notably, 25% of patients with positive family history and age of onset before 50 years were BRCA1 mutation carriers. In summary, the high frequency of BRCA1 and 2 mutations in our population suggested an enrichment of genetic factors in young cancer patients and support the need for family-based models of risk assessment and genetic counseling coupled with interventions to reduce the risk. Lately, we expanded from screening a few specific alleles, as already discussed, to studying a large panel together. This is made possible by the recent advances in genomic technology that enable simultaneous sequencing of multiple genes, and by the fact that the later controls that were recruited in later years were matched relative to the cases. Now, the genes that were included in the panel as shown, so many of them. The cohort consisted about 1136 cases and almost 1,000 controls. In all, 14.7% cases and 1.8% controls carried unambiguously damaging mutation in the breast cancer gene. And 4 of them contributed the most risk, as we can see from this table, the top 4 up there. 10 other genes each harbored a damaging mutation in 1 or more patients. BRCA1 and TP53 mutation carriers were generally younger than other mutation carriers. Moreover, although most patients with triple negative breast cancer carry no BRCA1 mutation, most BRCA1 carriers were more likely to be triple negative. So from the foregoing, we may conclude that in our studies, beyond just panel sequencing and single gene determination, so further pursuit was to examine common genetic variants that have been identified from genome-wide association studies with breast cancer risk in women of African ancestry. GWAS improves discovery of cancer genes, susceptibility genes, from genotyping of single tandem repeats and single nucleotide polymorphisms called SNPs. They allow successful identification of many new susceptibility alleles in the human genome. This is made possible as a result of advances in microarray technologies and being able to interrogate so many genes using a single panel. So to do this, we entered into partnership with individual researchers, and we also pulled data from some other collaborations together, as you can see in the next table. Okay, there already. So we participated in many of these tests with others, and below is a summary of some of the findings from the analysis of this. Next slide, please. So we did all this, and we're able to look in so many aspects. As you can see, association of breast cancer with other low penetrance diseases, some of which are listed there. Next slide. And this, but I'll just pick 1 or 2 of them and summarize. We investigated the association of genes in the insulin-like growth factor signaling pathway with breast cancer risk in Nigerian women. Extensive studies before had shown that studies had established or supported that there's a major role for insulin-like growth factor 1 signaling pathway in breast cancer pathogenesis. So we looked into this in summary, and we assessed genetic variants in this signaling pathway in many genes and their association with breast cancer in our women. We then confirmed the results in comparing with the African American women. 34 SNPs, single nucleotide polymorphisms, were analyzed for association with breast cancer in the 2 population samples. We found an association of breast cancer risk in African American women in parts of 2 genes on 1 of the chromosomes, which we subsequently replicated in Nigerian women. The association was statistically significant in both populations. The finding of a significant association in 2 independent populations of African descent and the consistent localization in these two populations and the biological possibility of the association between the candidate genes and the phenotype provided strong evidence for association with this locus. This was the first study to report association between genetic variants and breast cancer risk in women of African ancestry in the US. Now, there are so many other pathways that were explored, but I've been warned that I should make my presentation as simple as possible. And with the I don't want to lose my audience, so I will not go into the details of most of the findings. But suffice to say that we explored many pathways to look at how they interact with genetic changes that eventually result in breast cancer and what association occurred between them. We look at the urine diphosphoglucoronidase A transferase pathway. We did ancestry shift refinement mapping. We also looked at the association of breast cancer risk with other diseases susceptible genetic variants. We look at the effect of type 2 diabetes gene genetic pathway in the etiology of breast cancer and that of breast cancer. We also looked at the mTOR mammalian target of rapamycin pathway and its effect on breast cancer. Maybe I'll just say something about this because of its impact on breast cancer progression. The mammalian target of rapamycin, the mTOR pathway, is well known for its association with breast cancer recurrence and survival and has been a focus of study, whereas there's a paucity of data from Africa. So our group examined about 50,000 SNPs in 61 mTOR pathways, and we combined so many data together. Now we found that there were associations. Our group examined almost 50,000 SNPs using samples from so many places. The mTOR pathway was significantly associated with overall and estrogen receptor negative breast cancer risk. So overall, and then in estrogen receptor negative breast cancer risk. These associations were driven primarily by two genes for ER negative breast cancer, and two significantly were associated with overall risk on the gene-wide level. Now, this study provided new insights into the biological relevance of the mTOR pathway in breast cancer progression and underscored the need for more genetic epidemiological studies of breast cancer in the African diaspora. We also look at vitamin D pathway, microRNA biogenesis pathway, the EPO pathway, as well as the flip-flop phenomenon. Let me just talk about this and then I conclude. Now, genome-wide flip-flop phenomenon. Genome-wide association studies partnership with online biotics training institutes like the CITI and the 3 studies. I think people think more of biotics when they mention my name than oncology. It's been 2 decades of activities, hard work, learning opportunities and challenges. The initial days were quite tough and rough, trying to place a trail in an uncharted path, especially in a setting with no prior experience in research of such magnitude and involvement. This is not a praise-singing piece, but permit me to say that back home in Ibadan, the beginning was rough and tough. But all credits for the sustainment of this work locally in those early days go to Dr. Clement Adebamowo, whose doggedness, hard work, tenacity, stubbornness, and brilliance ensured continuity in spite of physical, mental, administrative, infrastructural, and system odds that existed. The challenges were many, including issues with time, having to fragment limited time among many competing demands and necessities, meeting timelines, electric power supply, quality of biological materials, human weaknesses and frictions, clinical issues, coping with chemotherapy needs of patients, training of residents and medical students, initial delay in publications because of the nature of the study and the write-ups, and research demands on family, social life, health, and personal comfort. What's the future direction of breast cancer research in West Africa? Well, there's still a lot to do. We don't know a lot about breast cancer. So I won't go into all this. What we find is just a summary of what needs to be done. Acknowledgements. Listening to this presentation, I believe you would have seen that the reports presented here have been the work, the contributions, and the outputs of many people and groups of workers, both locally and internationally. The thrust has been on me to stand before you and present the summary of their work to you. If there be any acknowledgement, any scholarship, or any semblance of accomplishment, it is all theirs. Whatever gaps or faults or failure to explain or present concepts clearly that you may have noticed in this presentation are entirely mine. It will be another lecture if I have to mention everyone who has been involved in this work from the beginning to date. I wish to acknowledge all our patients, dead and alive, their families and the controls for their invaluable contributions to knowledge, to science, and to societal good and progress. The funders of this work, and there are many, and mainly from the US of America, deserve special mention, an expression of gratitude. What our own national governments and well-endowed people will not do, foreign individuals, groups, and governments are doing. Some say it is often beneficial to them, that is the funders, but I say it is more blessed to give than to receive. I express sincere appreciation to all our collaborating partners and institutions in Nigeria, in Africa, and beyond. Many thanks to our resident doctors, research nurses, and students. My own base deserves special mention, my alma mater, my university, my College of Medicine, and my department, the Department of Surgery, College of Medicine, University of Ibadan, and University College Hospital Ibadan, Nigeria. It's a great privilege to belong to this same department and walk the same corridors of the same institution as many surgical giants in the likes of Victor Anuma Ngu, Latunde Odeku, Turiola F. Sholanke, Olajide Ajayi, Oluwole Gbalagutan have worked. Gbalagutan Ajao have worked. Some of these greats have gone, others are still alive and well. But whether gone or alive, they left behind them in the department another generation of seasoned academic surgeons, great teachers, and consummate clinicians, amongst whom are the Ladikos, the Shokumbis, the Adeboyes, the Oluwatosins, and many other brilliant senior colleagues. I belong to the third generation, and I'm highly honored that you accepted me into your fold and have trained me to stand here before you, representing you. I thank all the other academic, laboratory management, and administrative staff of our two institutions for the support of 2 decades. I owe a lot of special gratitude to my senior colleagues and colleagues in the Ibadan General Surgery Forum, and to my 2 able lieutenants in Surgical Oncology Division, Adeyinka Ademola and Omobolaji Ayendepo, for being so friendly, so accommodating, and so pleasant. Omobolaji Ayendepo was to come to leave Ibadan yesterday for this lecture and go tonight, but a last-minute event occurred. He had to cancel the trip. He's the most junior, so he has to do almost everything. Please permit me to identify 3 people who have been the tripod of this project from the beginning. Professor Gladys Adeyinka Falusi, Olufmilayo Olopade, and Clement Adibamowo. Professor Falusi midwifed the joining of Fumi Olopade and Clement Adibamowo in research matrimony. Their union has been blessed with many sons and daughters, including many grandchildren. I think it will not be modest of me to say that I'm their firstborn child. Professor Falusi is retired. She's former director of Institute of Advanced Medical Research and Training College of Medicine, University of Ibadan. Professor Olopade, a quintessential researcher and illustrious alumnus of the great UI Ibadan, and a winner of many laurels and awards, both locally and internationally, is the overall PI of this project. She's of the section of Hematology Oncology, University of Chicago. Dr. Adibamowo is presently Professor of Epidemiology and Public Health in the Department of Epidemiology and the Associate Director for Population Sciences for the Greenbaum Cancer Center at the University of Maryland, Baltimore, US. The collaboration was primarily between Fumi Olopade and Clement Adibamowo. I came into the picture by virtue of my working under him, under the latter, as my boss. He left Ibadan for the US in 2009 and transferred all the responsibilities to me, although before then much of the burden of the work had been on me when he was away on sabbatical leave. Clement Adibamowo is a clinician par excellence an unrepentant optimist, a brilliant visionary, a phenomenal scientist researcher. He is my great mentor, my brother and my friend. On a sad note, two pioneer members of the local team, Mr. Fagbemi in the Surgical Research Lab, and Professor Effiong EU Akang of the Department of Pathology, and another team member that came on board later, Professor Abidin Uluwashola of the Department of Pathology, have transited to the great beyond. In the early days, Mr. Fagbemi and Professor Adebamo were most days behind in the lab, late into the night when others had gone home. Professor Akang was the unassuming, hard-working pioneer pathologist on the project in Ibadan. Professor Uluwashola, passionate, energetic, unpretentious, passed on in 2018. We acknowledge their contributions to the Nigeria breast cancer study. Before I stop, I must acknowledge my late parents, my siblings, extended family members, my in-laws for their love, their sacrifices, and contributions to making me who I am today. Of note are my two sisters, the elder and the younger. The elder sponsored my university education in the early days until she lost her job when I was still in preclinical school. Thereafter, the journey was rough, but I scaled through. While I was still at the preclinical school, while the younger's husband sponsored my sojourn in the United Kingdom to pursue the fellowship of the Royal College of Surgeons of Edinburgh, it's gratifying that I did not waste their sacrificial investments on me. Essentially, my life revolves around three axes: home, church, office, in that order. For me, the second, the church, provides the basis for the peace and stability in the first, and the grace, serenity, and support for the third. I therefore wish to acknowledge the agape love, the sincere prayers, the priceless fellowship of my beloved brethren in Christ, both in my denominational affiliation, the Deeper Christian Life Ministry, or Deeper Life Bible Church, and all my friends in the Universal Church. I thank you. I thank my wife, Mary Posede Ogundere, my best friend, my great sister, and my caring mother, all rolled into one. She possesses the biblical attributes of a virtuous woman. Our union fulfills the scriptural truth that whoso findeth a wife findeth a good thing and obtaineth favor of the Lord. Our union is a living testimony to the fact that God is truly the best matchmaker. I recognize our three children, faithful daughter, trusted son, treasured baby, who together with their mom and by the grace of God make our home a true home. I offer special thanks to my highly intelligent and hardworking protege and my right-hand colleague, Omobalaji Ayedipo, who assisted with the stuff at the beginning of working on this presentation when the journey appeared like an impossible one. I will be an ingrate if I fail to mention the laudable contributions of the three reviewers of this write-up. They trimmed, sliced, changed, replaced, added, dotted, crossed, corrected to make it worth reading before you this afternoon. First is my teacher and my boss, right from Surgery 1 Posting Medical School, through residency in Ibadan, and up to date is my teacher, the one and only JKL. No one shares those initials with him. The second is my friend and highly cerebral colleague, Amos Adeleye, a neurological surgeon in Ibadan. And the third is the virtuous woman in our home. Finally, the president of the West African College of Surgeons, members of council, past presidents, fellows, and members of the college, distinguished ladies and gentlemen, in ending this talk once again, I wish to acknowledge with all humility and sense of gratitude this great honor that you have bestowed on me. Of course, I return all glory and praises to him who created the heavens and the earth, and in whom we live and move and have our being. I hope you will all join me in echoing with the sweet psalmist of Israel, who says, I will lift up my eyes unto the hills, from whence cometh my help. My help cometh from the Lord, which made heaven and earth. Thank you all. and gentlemen, the lecture has actually lived up to expectations.
Please, can you kindly sit down? It is our tradition that silver and gold we don't have. But after such a brilliant presentation, it has become a norm of our college to have something, a memorabilia of some sort, presented to the guest lecturer. I have the singular honor to make this presentation on the authority of our council and with the approval of fellows of this college.
Ladies and gentlemen, we now come to the end of the lecture. There's three quick announcements. Copies of this lecture are available at the registration stand account section for a small fee. Lunch will be served where it was served yesterday. However, council members and invited guests should still wait behind for their meal tickets. They're going to have a lunch at the hotel restaurant, Le Manger.